Dear fellow hackers and esteemed judges, today I will be talking about Geofence Software System in terms of ensuring that unmanned aerial vehicles, UAVs, do not go into any restricted areas such as buildings to ensure that they do not crash into them. And as it says here, it's about drone flying interfaces made easy for the entire family. So in the contents, we have 6 main features. We will first talk about the background of our project. We will talk about why we undertook it and our inspirations behind it. Then we'll talk about features which have to do with the software Geofence, the architecture of said software, and the simulations that we run to see how it works in reality and the results we got from it. After that, we interpret the data and we'll show that in our conclusion. So in our background, we find that UAVs, drones, are great devices. However, they do have the tendency to cause damages, to not work as they are intended. And so we have gone through great pains to meet the UAS traffic management requirements, as you can see in these 3 main requirements, as well as healthy safety concerns. We have also used open source tools and data which you can all find on GitHub.
I'm going to introduce you the feature of the Geofence software. So firstly, we construct the whole software based on the graphic information system, GIS. The data was exported from the OpenStreetMap, and with the help of the PostgreSQL and PostGIS, we're able to calculate the distance, the bearing, and also the Boolean relations between objects and the UAVs. That's how we make the no-fly zone possible in the software. And also we also made the advisory with a visual and audio alerts. So if you approach the building like in a quite fast speed, and then there will be like audio alert says stop, and also there will be a visual alert, a flashing stop sign gonna appear in your screen. And in addition to the mobile side software, we also build a desktop client to help the users to simulate, to test the UAV in the certain areas. And in this example, we use the Cranfield University, which is a small village 70 kilometers north from London. And the display is color-coded with the avionics standard, so you will find the same color scheme on every manned aircraft and professional unmanned aircraft. The architecture of this software consists of 3 parts. So the first is the data source, and then the API, which organizes the data into the shapefile, and also convert it into the database. And then we do the calculations using the PostGIS with the help of the Java JDBC drivers, so we can manipulate the database easily. And after we get the raster image inside the database, we export it as the PNG and display the image on our graphic user interface, also built with Java. And in addition to this, we also built the XML parser to further explore the map data coming from all kinds of sources.
Along with our test on the campus of Cranfield University, we have also hypothesized how such software would work closer to home in Sheffield on the Diamond building. So as you can see in this picture, point A to point B is the flight path that the drone follows, and the first flight path is in black, represents a black line that goes right through the diamond building. Now, that's considered the wrong path, the bad path, because as you can see, it either crashes into or it flies over a restricted area, which is why it's in red. So our program would effectively make the drone turn. It would go around the diamond instead, and by going around, it would get to point B, so the same destination as the black line. So this is detailed as the green line in this diagram. Now, our results, which we derived from our findings at Cranfield University, we found that the UAV's zone of operation, it detected obstacles. As you can see, the red zones are buildings. These are areas that the UAV intentionally missed, because knowing that if it went anywhere near, the interface would yell stop. That's a visual indicator, and there would be a beeping noise, an alarm to ensure that the user knows that it's restricted access. So it would go towards the green areas, which are unrestricted. This visual aid is common. It's a common avionics color scheme that pilots rely on, and we think the same can be used for drones.
To conclude the Geofence software system, it remains an important tool in carrying out the flights for the UAV operations in areas with various obstacles. Thus, there's an improvement in the operability of the UAV from private bridge, and in order to further develop this software system, we suggest the users or the further developers to look into the 3D image model integration, and also if they can work with the authorities so they can integrate the airspace regulations directly and have it operated on every legal owned drones, so this will reduce lots of hassles. And also we need to develop a proper manual for the software, and currently, except us, it's very hard to configure and to really use it. So we need to improve that. And also we need to develop the dynamic buffer range depending on the UAV speed. Currently, the buffer range is set manually as 0.0012 degree of the Earth's latitude and longitude. So that's the Geofence software system. Thank you for your listening, and if you have any question, please leave any comments on our video or on our debug post site. It will be appreciated. Thank you very much.